Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is BET analysis method from Unit 4 Nanostructures and Characterization Techniques. On completion, the students will be able to understand the concept behind bit analysis method and also explain the procedure, applications and limitations of bit analysis in nanotechnology. Bit analysis method, BET, stands for Brunner Emmett Teller analysis method. It is a method for measuring the specific surface area of materials by absorbing nitrogen gas or another inert gas at liquid nitrogen temperature and analyzing the gas adsorption isotope. Principle. This method extends the Langmuir adsorption model to multi-layer adsorption. It assumes physical adsorption occurs in layers. Adsorption is localized at specific sites and there is no interaction between the adsorbed layers. The first layer adsorption enthalpy is different from the subsequent layers, which are equal to the liquefaction heat of the adsorbate. The difference between adsorption and absorption is that in adsorption, the molecules get stick to the surface of the material, whereas absorption means the molecules are absorbed or it is completely taken into the volume of the material. Nanomaterials often have extremely high surface area to volume ratios which significantly influence their physical, chemical and mechanical properties. The bit analysis provides a quantitative measure of this surface area, thereby making it critical for characterizing the nanomaterials as nanoparticles, nanotubes, nanowires and other nanocomposites, and also evaluating catalysts where surface area directly affects the reactivity, and designing sensors, absorbents and energy storage materials, and monitoring the synthesis processes to control particle size and porosity. Bit analysis procedure. The sample is degassed to remove the contaminants. Then it is exposed to nitrogen gas at a liquid nitrogen temperature. The amount of gas being adsorbed is measured at various pressures. Bit equation is applied in order to calculate the specific surface area in meter square per gram, monolayer capacity, that is the volume of the adsorbed gas, and the pore volume and pore size distribution. Interpretation of bit data for nanomaterials. For different parameters, can observe what it indicates in the nanomaterials. So, high surface area, that means the particle size is small and it is good for catalysis and drug delivery. Pore size distribution, which based on which it indicates the materials being mesoporous or microporous structure. Hysteresis in isotherms, that we can obtain the pore shape or type, that is it can be a cylindrical or it can have ink bottle pores. For example, carbon nanotubes might show high surface area but it will have a low pore volume, and mesoporous silica nanoparticles will be having significant surface area with well defined pore sizes. And the limitations of this bit method in nanomaterials are BET is less accurate for very low surface area materials, and it assumes a non-interacting monolayer in first layer adsorption, and it may not always hold in complex nanostructures. For microporous materials, bit theory may overestimate surface area, and alternative models, that is T-plot or DFT, may be needed for further analysis. Bit equation. The bit method assumes multi-layer adsorption of gas molecules. Typically, nitrogen gas at liquid nitrogen temperature, that is 77 Kelvin, is used, and this is representing the bit equation. In this equation, V is the volume of gas that is adsorbed at pressure P. Vm is the monolayer capacity. Po is the saturation pressure of the gas, and C is the bit constant that is related to the energy of adsorption. From the above, we can obtain the specific surface area is calculated as Vm Na sigma by V, where Na is the Avogadro's number, sigma is the cross-sectional area of the adsorbate molecule, and V is the molar volume of the gas. Bit analysis in nanotechnology. In nanotechnology, the surface area is a critical property as it affects the catalytic activity of the nanoparticles, adsorption and sensor behavior, drug delivery efficiency, that is in nanocarriers, energy storage, example battery electrodes, supercapacitors, etc. This bit analysis helps in comparing the surface area of different nanomaterials, evaluating porosity and pore volume, and also assessing the changes after surface functionalization or doping. Bit analysis outputs are specific surface area in meter square per gram, monolayer adsorbed gas quantity, bit surface plot, that is a linear portion for bit calculation, and pore size distribution. Applications of bit analysis. The surface area measurement of the catalyst, zeolites, clay, and activated carbon. Quality control of powdered materials. And also, it helps in studying the porosity and adsorption capacities. And it also has certain limitations. We have to assume a uniform surface for obtaining the bit analysis. It assumes multilayer adsorption only, and therefore it is not suited for micropores that are less than 2 nanometer, and that it is also observed to be temperature dependent and usually done at 77 Kelvin with nitrogen. Quiz questions on bit analysis method. Write down the equation for bit analysis method. State the applications and limitations of bit analysis method. Thank you.